Hello.
Hello.
Again, guys, come on.
Again, you're leaving it all to him. I had to like work to get it, and they mentioned that you weren't here last time that we did a recording. So. Alrighty, let's take a look at our notes. You are going to see me draw in my usual black. I am going to have two different colors going out. My highlighters didn't get back to me at the end of last class period. Yeah, so I'm very sad. So I can't throw highlighters at you, really. So, sorry. Oh, Jiminy? Yeah, he's in again. No, he loves you guys.
No, we love him too, just not right now.
Just not right now. Alrighty. So, last time we were together, we were talking about graphing systems of linear equations. These were basically a bunch of lines all graphed on the same piece of graph paper, and the solutions to these systems were anywhere the lines crashed into each other. But all the lines had to crash at the same point. Now we're going to step this one step up, and we're going to talk about systems of linear inequalities. And so these are the ones that had the line, and you colored on one side or the other, and the line was either solid or dashed. And so that's what we're working on today. But this time, instead of there being just one solution possible, we can have an entire region of your paper be the location where the solutions live. And so we need to cut your paper into 4 pieces and talk about them in terms of quadrants. Quadrant 1 has both x and y coordinates positive. Quadrant 2 has the x negative, but the y is positive. Quadrant 3, they're both negative. And quadrant 4, the x is positive, but the y is negative. Okay? So let's practice stating where points live, which town, quadrant 1, 2, 3, or 4. Which quadrant can you locate the coordinate 1, 4? Quadrant 1, because both of these are positive, this lives in quadrant 1. What about the point -3, -4? Quadrant 3, because these are both negative. What about -2, +2? Quadrant 2, because quadrant 2 is where x is negative and y is positive. All right, don't forget that our system of linear equations is just a group of 2 or more linear equations with the same variables. And so we're going to be sending this to linear inequalities, which is the same thing, but we're just shading. So let's get into practicing. We're going to graph this system of linear inequalities on the same coordinate plane. I'm going to color one of them yellow. I'm going to color the other one blue. And that way we can see which inequality is which, and we can see if there's any overlap of their solutions. All right, going to graph this like I would normally. This is +2, so my y-intercept is a positive. It's a +2. And then my slope is not visible, so it's a 1. So that means I'm going to go up 1 to the right 1. Up 1 to the right 1. I only need to draw 2 points to create the line, and once I have the line, I'm going to grab my handy dandy line maker tool. And there is my boundary. Y is greater than x plus 2. Now I have to decide, is this a solid line or a dashed line? Look right here. That means it's dashed. So I'm going to grab one of my markers, and I'm going to try to make that a dashed line. I don't have a good marker with me. No, I do not. So I'm going to use this one. So I'm going to make this a dashed line. I'm going to go ahead and dash it with my highlighter. All right, there's my dashed line. The next thing to do is decide which side of this line I'm going to color on. Am I going to color on this side over here or this side over here? the way to tell is to use some test points. To pick the test point, pick any point that you want as long as it's not on the line. Any point. I've been showing how to pick with 0, 0, but I'm going to give you guys the freedom to pick any point that you like so that you can see that this still works. -3, +4? Okay. So I got told to use the test point -3, comma 4. All right, so I'm going to take this equation, y is greater than x plus 2. And instead of x, I'm going to write a -3, and instead of y, I'm going to write a 4. And when I simplify this down, I get a statement that says 4 is bigger than -1. So the question is, true or false? True. All right, that's true, which means I'm going to color where this point lived. This point lives over here, and so I'm going to color over here. That make sense? All right, I'm going to repeat for the blue one. Intercept is -1. Slope is -2. Down 2 to the right one. There's some side conversation that can be saved for later, please, ladies. Thank you very much. All right, there's my equation. Is this a solid or is this a dashed? Solid. So I'm going to take my highlighter. I'm going to make sure that's a nice solid line. I can already see the colors blending a little bit. Wherever you see the colors blend, that is in your solution for the system. All right, we're going to take another test point, but we're going to test now the blue. So can I have someone else give me a point, any point not on the blue line?
-6, 6.
-6, +6?
Yes.
Okay. So -6, +6, way out there is my test point. All right, I'm going to take this inequality. And everywhere I see an x, I'm going to put a -6. And everywhere I see a y, I'm going to put a +6. And I end up with a statement that says 6 is less than or equal to 11. True or false?
True.
That's a true statement. And so the side of the line where -6, 6 lives, which is over here, that's the side of the line I'm going to color.
Ma'am, do you have a green highlighter?
Do I have a green highlighter? I don't have a green highlighter of my own anymore. It got borrowed and not returned. Your friend has one though.
You didn't know you had one yourself.
Yeah, I didn't know he had one either. He just handed you one. It was awesome.
He's my Spider-Man.
He's your Spider-Man. There it is.
Yeah.
I like using highlighters because when you color highlighter over highlighter, the colors literally change. And so color in these sets so that you can see the color change. My solutions are here. Here, there be solutions. It's like a pirate map. There they are. Everywhere where the two solution sets overlapped. Here, there be solutions.
Oh, look at that.
What quadrants are these in?
2 and 3.
Remember that this is
Oh, wait.
quadrant 1,
Oh, those on
this
all
is
of them.
quadrant 2,
It's in all of them.
this is quadrant 3, and this is quadrant 4. The solution set to the system of inequalities, as he stated, do exist in quadrant 2 and in quadrant 3. I'm not going to have any solutions to the system in quadrant 1 or in 4. I have solutions to the individual inequalities, yes, but I don't have solutions to the system, all of them together, in anywhere but 2 and in 3. Make sense? All right, let's do one more practice. I've got on the back, I've got 3 more examples. Look over them and choose the example that you're like, I don't know. The bottom one? This one? All right, taking a look at this one. If I had to guess why you picked it, I would guess that you picked it because you're not sure what the graphs of these are going to look like.
Or maybe because plus one.
Oh, because we're not adding or subtracting anything? Okay. Well, let's look at what these kinds of lines look like. A y equals kind of line is always going to be some sort of horizontal line. An x equals something is always going to be some sort of vertical line. All right, so I'm going to go to y is 3, and I'm going to draw a horizontal line at y is 3. And then I'm going to look at the sign, and I'm going to realize that this should have been dashed. And so I'm going to color in my dashes really big and obnoxious so everyone can see. Going to color this in yellow. And I want where y is less than 3. With a horizontal line like this, it's really easy to see where the y values are smaller than 3, isn't it? Like, if I pick 6, 6 isn't smaller than 3. 6 is bigger than 3. But 1 is smaller than 3, and so this is the side where my solutions to y less than 3 live. We're going to do the same thing with the x equals. This is a vertical line. X equals 1. My vertical line boundary is here, and it's solid. I'm going to go ahead and label. It is solid. And I want all the x's that are bigger, ladies, later please. I want all the x's that are bigger than 1. It's easy to see that over here on the right hand side is where the x values are bigger than 1. So I'm going to color on this side. And once again, my solution set lives wherever the 2 colors interact. So my solutions are here. What coordinates? What quadrants, rather? 1 and 4, because this is quadrant 1 and this is quadrant 4. Good. Let's list off 3 coordinate points that are going to be in the solution set. Can I get 3 different people to give me 3 different coordinates that they think belong to the solution of this system? If you're not sure, you can just give me any 2 points and we'll check it.
Oh, the coordinates.
Yep. So I need 3 different people to give me 3 coordinates.
That,
What was it? Positive 2, negative 5. Okay, one other?
positive 4, negative 3.
Positive 4, negative 3. Someone else? A coordinate? Any coordinate?
Negative 6, positive 6.
Negative 6, positive 6. All right, so let's look at each one in turn. Here's 2, -5. That is somewhere in what I've colored green. It's where the two colors are overlapping. So that is part of the solution. 4, -3. 4, -3. Also where both of those things intersect.
Oh, you have the X's in the front, right?
-6, +6. This is not any solution.
Yeah.
So let's pick another point. Let's find something that's within the solution set.
5
5,
and -2.
-2. Here's 5, here's -2. We are somewhere in the green, so we're good.
We made a line.
We ended up making a line, yeah.
Yay.
On accident. Feeling okay with this one? Making sense? Do you want to see another example or are we done? We're done? All right, thank you guys so very much.